Canada quietly sent aluminum across the border, and the United States depended on it without worry. But then, everything changed. A move meant to pressure Canada is now opening new doors for Canadian producers, while many American factories are facing higher costs and growing uncertainty. The aluminum trade relationship between Canada and the United States was one of the most predictable industrial arrangements on the continent. Canada produced, America consumed. The arrangement worked because the economics made it work. Canada had abundant, low-cost hydroelectric power to run aluminum smelters. And the United States had enormous manufacturing demand that absorbed almost everything Canada could produce. By 2024, Canada was exporting roughly 13.4 billion Canadian dollars worth of aluminum annually, with more than 94% of that total flowing directly to the United States. American factories processed it into vehicles, aircraft, electrical systems, aerospace components, and beverage cans. The supply chain was integrated, reliable, and taken for granted on both sides of the border. Then, the tariffs changed everything. The United States imposed a 25% tariff on Canadian aluminum in March 2025. By June 2025, that rate had been raised to 50%, the same Section 232 escalation applied to Canadian steel. The stated objective was to encourage domestic American aluminum production and reduce dependence on foreign supply. What happened instead is now documented in trade flow data that American industrial buyers are examining with growing alarm. Canadian producers did not wait for the tariff dispute to resolve. They diversified. Europe emerged as a major alternative destination for Canadian aluminum shipments almost immediately after the tariffs took effect, with EU-bound shipments rising sharply in the months following the June escalation. Canada's share of total U.S. aluminum imports declined. Canadian producers found new customers, and American buyers were left looking for alternative sources that carried entirely different risk profiles. Canada's aluminum has a specific commercial advantage that drove European interest and makes it difficult for alternative suppliers to compete on equivalent terms. Quebec is home to 9 of Canada's 10 primary aluminum smelters, with a 10th operating in Kitimat, British Columbia. The smelting operations run on hydroelectric power, one of the cleanest energy sources available for an energy-intensive industrial process. Canadian aluminum therefore carries a lower carbon footprint per ton than aluminum produced using coal or natural gas-powered electricity, which describes a large share of global production capacity in China, the Middle East, and other competitive suppliers. As European industrial buyers operate under the EU Carbon Border Adjustment Mechanism, which imposes carbon costs on imported goods based on their production emissions, Canadian low-carbon aluminum becomes progressively more commercially attractive relative to alternatives. The tariff that Washington imposed to redirect Canadian aluminum away from American buyers effectively pushed a premium low-carbon product toward the European buyers who are most motivated to pay for exactly that carbon profile. America's response to losing reliable Canadian supply was to turn toward Middle Eastern producers. Nations including the United Arab Emirates, Bahrain, Qatar, Saudi Arabia, Kuwait, and Oman gained importance within America's aluminum import network as Canadian flows redirected. The fundamental problem with that supply diversification is geography. Middle Eastern aluminum, alumina, and bauxite shipments transit through the Strait of Hormuz, one of the world's most critical and most vulnerable maritime choke points. Approximately 20% of global petroleum trade passes through the strait daily. In the current environment, with the Iran conflict actively affecting regional shipping patterns and the strait's operational status subject to geopolitical disruption, any supply chain that runs through that waterway carries a risk premium that Canadian aluminum shipped directly from Quebec or BC to American Atlantic and Pacific ports never required. American automakers, aerospace firms, beverage can manufacturers, and defense contractors are now dependent on aluminum supply that transits a choke point whose disruption is documented and ongoing. The domestic American production alternative that tariff architects pointed to as the long-term solution remains years from delivering meaningful capacity. A proposed $4 billion aluminum smelter in Oklahoma, the most advanced domestic expansion proposal in the market, is still in early development stages and remains years away from contributing production volumes at the scale American industrial demand requires. Building a new aluminum smelter at commercial scale takes 5 to 8 years from initial investment decision through construction and commissioning. The energy cost structure required to operate it competitively against Canadian hydroelectric powered production requires access to electricity rates that the American grid, with its predominantly fossil fuel generation in the South and Midwest, does not currently offer at equivalent cost. The tariff exists now. The domestic supply response, even in its most optimistic form, cannot arrive for years. Europe is not waiting for that timeline to resolve in America's favor. The aluminum redirection from Canada to Europe is part of a broader strategic resource partnership that European governments have been deliberately building since Russia's invasion of Ukraine disrupted the continent's energy, industrial supply chain assumptions. In May 2026, Germany's CFFCA agreed to purchase 1 million tons of LNG annually from the proposed Keyside Lissams LNG project in British Columbia for up to 20 years. That single contract represents a 20-year structural commitment between Canadian energy supply and German industrial demand, the kind of long-term offtake agreement that reshapes supply chains for a generation rather than responding to a quarterly trade dispute. Canada is simultaneously positioning itself as a European supplier of aluminum, uranium, potash, critical minerals, hydrogen, and rare earth elements, a resource partnership built on long-term contracts rather than spot market transactions, and therefore far more durable than the relationship a tariff can disrupt and a tariff reduction can repair. The automotive industry dimension of the aluminum supply shift is the element that makes the story directly relevant to American consumers, rather than just industrial buyers. Aluminum is no longer a supplementary material in vehicle manufacturing. It is a structural necessity. Ford's aluminum-bodied F-150 remains one of the most commercially successful vehicles in American automotive history, a truck whose weight reduction, fuel economy, improvement, and towing capacity gains depend entirely on substituting aluminum for steel in its body structure. Electric vehicles amplify that dependency further. Battery enclosures, structural components, thermal management systems, wheels, and chassis elements in EVs all use substantial aluminum volumes. Because weight reduction in an electric vehicle directly extends range, the metric that determines consumer adoption, as aluminum costs rise from supply disruption, tariff premiums, and the risk-adjusted pricing that Middle Eastern Hormuz transit supply now requires, production expenses increase for every vehicle platform that uses aluminum intensively. Automakers can absorb some of those cost increases, initially through margin compression, but sustained aluminum price elevation driven by structural supply displacement rather than a temporary market fluctuation translates into vehicle pricing decisions, manufacturing investment choices, and platform development strategies that affect what vehicles get built, where they get built, and at what price they reach American consumers. General Motors projected $3 to $4 billion in tariff-related costs for 2026 across its operations. That figure encompasses steel and aluminum inputs alongside other tariff-affected components. The aluminum component of that cost pressure is specific to the supply displacement that Canadian aluminum tariffs triggered a self-inflicted input cost increase that flows directly from the policy decision to impose 50% duties on the most reliable, lowest carbon, most geographically proximate aluminum supply available to American manufacturers.